Hey, my name is Sawyer McLean, and today we're going to be working on doing an intro to Python programming. We're going to be doing a brief overview of some computing topics first, and then we're going to dive into a really basic um, example that we can compare and contrast with a more difficult language, which is C. So first off, what is a computer? Well, broadly speaking, it's a machine. It can be either mechanical, electrical. Some are theorized to even work on, fluids. It doesn't really matter. Um, that can change operations based on user inputs. So it can be set up with a series of instructions from a human, and then it can be left to perform its task on its own. It won't need any other input from the user or the operator unless that is part of the requirement, like it's asking for names or something. And then it can output some kind of information to the user. These computers would be completely worthless if we didn't have some way of reading the results, of reading the calculations that they're providing for us. So over here we have a picture of something that doesn't quite look like a computer to the modern day person, but it's a Jacquard loom. I think I'm pronouncing that right, which is an early, considered to be one of the first examples of a programmable machine. Essentially, the operator could put in a textile pattern that they wanted to create on a series of punch cards, and the loom would be able to read those punch cards and punch and create the textile. So in this case, the output would be in the form of some fabric, which is kind of a far cry from the text on the screen that we're used to today. So what is computer programming specifically? So that's the part where we write the instructions originally for the computer. They're just machines. They don't know what to do on their own. We have to tell them what to do in every instance. Every piece of software that anytime you've ever used a computer, everything that you've interacted with has been made by a human. Someone had to tell the computer exactly what to do and find a way to connect everything together behind the scenes. And so that's kind of what programming is. So there are many different kinds of languages that a computer can speak, so to say. Some of them are closer to what the computer natively speaks, if that makes sense. So, for example, the textile loom natively speaks punch card. So someone somewhere has to figure out how to translate, okay, what does this punch card mean in terms of what picture, what pattern is going to come out on the textile. And so that's kind of what that cloud is converting that into computer language. And so certain languages are further removed from that, certain languages are in that, certain crazy people, not crazy people, but if you're getting really into it, you can write in computer language is often referred to as assembly, which is the lowest language that we can understand before it turns into ones and zeros and doesn't really have any semantic meaning to humans. But we're going to be staying pretty far away from assembly, although I will be giving a quick example in a language called C, which is pretty vital to computers and is a lot closer to the computer language. So what's a program specifically? Well, that's the set of the instructions that the computer executes. So you can think of it like a recipe from a cookbook. You start at number 1 and you go down the list and you do what it says. And sometimes there might be instructions in there that say, if you're making cookies, it says repeat steps, 3 through 5 for each, glob of dough or whatever. So sometimes you might be doing things over again. There might be optional instructions in your recipe saying if you're vegan, you can substitute this out. But you're not vegan, so you don't care and you skip that instruction. Or you are, so you substitute cauliflower for bread. And then sometimes things can be moved around, which that doesn't really have an analog in recipes as much, unless you're getting really experimental with it, but we'll kind of see how that can apply in our example. So the language we're going to be learning in specific is Python. It's one of the most popular languages in the world right now, if not the most popular, in terms of just volume of questions online and the level of community and activity. A lot of these words here won't mean anything right now, but we're going to go over specifically what they mean in our example. Python is an interpreted language as opposed to a compiled language, which is what we'll see in our example. It's dynamically typed as opposed to statically typed, and it's high level, which means it's really easy to read. So we'll see in our, this will all make a little bit more sense when I can show you some code, and we can kind of get into the nitty-gritty of what this all means. So let's go ahead and bring up our console here. So I'm using an online compiler for all, or the programming environment, I guess you could say, called Replit, and it will let us kind of compare and contrast some of these languages. So first, we're going to start with a C program. This already looks pretty kind of weird and intimidating, but this is the bare bones C program, and when we run it over here, we can see that it prints out "Hello World." We don't need to go into exactly what's going on here, but it starts off with the main. This line here is essentially the first line of its recipe, and it's going to print "Hello World" out, and then return the number 0, and there's nothing left, so it's over. And 0 just kind of means that the program is okay. Now let's compare that to a Python program that does the same thing. That looks a lot more simple, right? Just print "Hello World," no weird characters in there. We've got some brackets, sure, but there's some some parentheses, but other than that, same thing. So if we run this, "Hello World," there it is. So the first thing that we can do is, and the first thing that we'll point out is that Python's an interpreted language, meaning that it runs in something called an interpreter. So if we go over back to our C example, you can see over here on the console that there's actually 2 steps that happen when we hit run. First of all, it calls this weird clang thing on our main.c file, and then finally it runs main. That's because this has to get compiled. Essentially, if we go back to our presentation, it has to get converted into computer language. And that step happens discreetly. This is another thing. So you write your program, it gets compiled into the computer language, and then finally is ran on the computer. Python, it just blasts out "Hello World." So what's going on? Well, Python is essentially like, it's kind of like the interpreter is sort of like a program in and of itself. And so it's running, it's sort of running on its own, and it lets us, it will read instructions one by one in real time. It does not, nothing needs to be done to it beforehand. So the upside is it's a lot cleaner, a lot easier to read, a lot faster to write and test in. The downside is it's a lot slower because we're essentially running code on a program that is also code, and so we're kind of up on another level. But for most purposes, computers are so fast nowadays that this doesn't matter. So the other upside of an interpreted language is we can just start typing and over here in the interpreter and start getting examples. So you can see this is interactive. So we can say print Sawyer McLean. There's my name. So we can't do that over here with C. Nothing. We have to do everything over here. It has to get compiled first. Over here in the interpreter, we're free to go. So we can start looking at other examples of things that Python can do. And these are pretty standard for most languages. So for example, we saw already that we have these things in parentheses. They're called strings. This means they're a string of characters put together. So like my first name is a string, and if we type it in there, it'll print right back to us. We can work with numbers too. Here's 5. 5 plus 5 is 10. 10 divided by 2 is 5. So we've got kind of like a little calculator thing going on here, and that's essentially what a program, what a computer is. It's like a calculator with a lot of memory that can run these instructions in order. So this is going to be probably the end of the first video. We're just to compare and contrast. In the next video, we're going to start going over all of the functionality of Python and start digging into what we can really do with it. Thanks.